Hello everyone. Today we'll learn about binary search tree, how to implement binary search tree in JavaScript, and we'll begin with creating a node which will keep track of our value and left and right. So let's begin. So we'll just create a class called node. We will have a constructor and it will take just value, and then we'll assign it to the state value, and we'll just keep this start. Previous is null for now, not previous. Left and this right is also null. Now to implement this, we'll create another class called, let's say, linked list, and this will have constructor which will take node, and this will be our root. So this we can take it from the constructor and assign it, or we can just make it optional. For now, let's just say it's null, or we can just leave it blank and assign it null, and we'll add values to the linked list using our methods. So the first method, let's create insert, which will be used to insert values into the linked list. So let's say value, and this is where we use our node class. So node equals to new node value. Now where do we add it? Now this is where we'll add this node into our linked list. So we check if this root is null or not present. In this case, we'll add it to this root equals to our node. So we have not initialized our linked list yet. We are first time initializing, and we are doing it like this, like we are assigning the first node as the root node. Else, or we can just use simple return, and then if we already have the root node, then we'll go and check if the value is less than the root node. Then we'll go leftwise, then we'll again check if that left node already has another node. So this way we'll go into checking the recursively. So that's why we'll create another method, and we'll call that method first. Let's say the new method insert node, so we'll call that method, and we'll pass the new method its root, not the whole root of the linked list, but which root we want to check with. For now it's this. So, and also the new node. Now let's implement this. So insert node, it will take the root and node, and now we'll check if the root, if the value, the node dot value is less than equals to root dot value, then we'll do, then again check if we'll go leftwise. So if root dot left is empty, so it's, if the root dot left is empty, it's not present, then what we'll do is we'll assign, so that way we know that is the last node that we have. Then we'll assign the root dot left equals to node. Now let's say this left is already present, that means we have more more children. So in this case, what we'll do, this will again call this dot insert node, but now our new root is root dot left, and we'll pass the node. And similarly, if this case we are going leftwise when the value is less, and we will go right if node dot value, we can add another if condition, or we can just go else, because we have already taken care of one case. We'll go just in the else block, that means the value is greater than, then we'll go right. So what we'll do, it will check if root dot right is not present, that means we will assign root dot right equals to no. And if it's again, if it's not empty, that means we have more nodes. This dot again will call insert node in recursive. So what we'll do, now our root will be root dot right and node. So in this way it will go recursively, and it will add the values. Now that we have inserted nodes into a linked list. Now let's say let's go with the search. Let's implement a search method which will do the tree traversal and search provider value. It will just take value and it will also take root, like what is the current root. From that we'll check the value. If it's greater, we'll go left from the root. If it's if it's less than the root value, then we'll go left. If it's greater than the root value, then we'll go right. For the beginning, for the initial purpose, when we do the search, we can just take it the default value as this dot root. So this is the full root of the our binary search tree. So this is the default value. Then we'll check if not root. If root is not present, that means we'll just let's say do it not found. If it's empty, not found, we'll just do return. If root dot value equals to value, that means we have found. We'll just do log found and value. Now let's say if the provided value is less than or equals to root dot value, that means we will need to go leftward. We'll just do console.log go left. This is where again we'll use recursion. We'll just call this dot search value, and again now root will be root dot left. And in the else case, when the value is greater than the root value, we'll go right. We'll just do console.log go right, and then we'll do this dot search value root dot right. Now let's say if it's working, what we'll do, we'll just initialize our binary search tree. I think we named our class wrong. This is not linked list. This is, let's say, binary search tree. bst equal to new bst. Now what we'll do, we'll just insert bunch of values. Let's say 5, and let's copy them. 2, 7, 15, 3. Now let's say we'll search bst.search 7. Let's go here and just run. As you can see, it found 7, but again it went ahead and like searched the whole tree, which is not correct. For that, as you can see, we did not return here. So once we find our value, then we should return. So in this case, we found it. Let's say we are searching for 3. Then again run it. Okay, go left because 3 is smaller than our root value. Then it went left. Then in that case, if 2, then 3 is greater than 2, then we are going right and found. If we just run search for that 7 again, see we are going right and found 7, and we are not running anymore.